This is a video presentation of Chapter 7, Section 5 in your textbook, which is entitled Box and Whisker Plots. Our objective here is to be able to display and analyze data in box and whisker plots. We'll begin with the essential vocabulary for this section. So we'll start off with box and whisker plot. What is a box and whisker plot? It is a graph that uses a number line to show the distribution of a set of data. A graph that uses a number line to show the distribution of a set of data. Lower quartile is the median of the lower half of a set of data. And recall, the word median implies it's the middle number when the list is in order from least to greatest. Again, the lower quartile is the median of the lower half of a set of data. Upper quartile is the median of the upper half of a set of data. Very similar definition. The upper quartile is the median of the upper half of a set of data. And the interquartile range is the difference between the lower and upper quartiles. The interquartile range is the difference between the lower and upper quartiles. So let's begin with the first question here, and what they're asking us to do is to use the data to make a box and whisker plot. So as you can see, the data set they've given us is the heights of different basketball players in inches. And what they're going to go through here step by step is the process on how to make that box and whisker plot. So as you can see, the first thing we want to do is order the data from least to greatest. And then we're going to find the least and greatest numbers, which are referred to as the extremes. And that's the term we use when we're making a box and whisker plot. And then we're going to identify the median, traditional median. And then if you recall the definitions, we had some other definitions that involved the word median. Those were the upper and lower quartiles. And we're going to find those numbers, which happens to be medians upon themselves. So the first thing we're going to do, obviously if we're talking about finding median, we want to put the numbers in order from least to greatest. So from this list of numbers as presented up top to this list of numbers is the same set of numbers, but they're arranged in order from least to greatest. And the first thing we want to do is find the lower and upper extremes. And remember, in this case, that's going to be the smallest number and the biggest number, so that's going to be 67 and 85. And then what we want to do is we want to go ahead and find the median. That's one of the numbers you'll need to actually create the box and whisker plot. I know we haven't actually seen one yet, but that's one of the numbers we're going to need. Remember, that is the middle number, and when there are two middle numbers, you're going to average those two middle numbers to find your median, which is in this case going to be 74. It's the average of 73 and 75. Then what you're going to do is you're going to find your lower and upper quartiles. That middle number, that 74 we just found, is going to split your list into two parts. As you can see down here, this last one, what's probably not in your note-taking guide is this little bar. Right? Everything from the 73 on down has become its own list of numbers. Everything from the 75 on up has become its own list of numbers. And again, the separator is this median. What you're going to do now is find the lower quartile, which is in the set of smaller numbers, and find the upper quartile, which is in the set of larger numbers. The quartiles are simply the median of each set. So we're talking about the median of what's from 67 to 73 and the median of what's from 75 to 85. And again, those are those middle numbers. Median hasn't changed. It's just what we're actually finding the median from. Remember, originally it was all 8 numbers. Now we're finding it from the 4 small numbers and from the 4 big numbers. As you can see, once again, there were 2 middle numbers there, so we're going to have to average to find those medians, those quartiles. So averaging 67 and 69 is 68, and averaging 75 and 81 comes up with 78. Now what you want to do, and you don't exactly have to do it this way, but what the book suggests to do is that you draw a number line, and above the number line you're going to plot a point for each value that we found in step 1. Remember, we found 5 different things. We found the small and the big number on the list, which was called the extremes. We found the median of the entire list, And then we found the median of the small set of numbers and the median of the big set of numbers, which are called the extremes. And you can see that's what we've done at the bottom of the screen, the red dots representing those 5 numbers. Now you don't necessarily have to sketch a number line to do this. Really, you can just lay down the 5 numbers. But what you have to do when you're making this is you're going to have to make your gaps or your distances make sense. For instance, if this is the gap from 67 to 68, which indeed it is on this number line, right, the gap from 68 to 69 could then not be from here to here, for instance. If you're saying this is a jump of 1, then that's always going to be the distance 1 on your chart. So make sure if you're not going to draw a number line that at least the gaps you're giving between the numbers make sense. Okay, so we've laid down our numbers on our number line, and that'll get us to step 3 now. What you're going to do is draw a box from the lower and upper quartiles, and inside the box draw a vertical line through the median. So what they're telling you is these 3 dots that are in the middle of the whole thing are going to be connected with a box, and as you can see, this one in the middle gets a line through the box at it. That is the box part of the box and whisker plot. And then what you're going to do is you're going to draw the whiskers from the box to the least and greatest values. This line that goes from here to here, and this line that goes from here to here, which connect the box to the small number and the big number, the extremes, are called the whiskers. The box, the whiskers, and you've made a box and whisker plot. Okay, so now what they're going to ask us to do is they're going to ask us to use the box and whisker plot in additional example 1 and the one below to answer the question. As you can see, this is about the heights of baseball players. Okay, so the A question here is asking me which set of heights of players has the greater median. So really what they're testing is, do you know now the different parts of the box and whisker plot? Remember, the median is going to be in the middle of the box, the one that has the line going through it, or somewhere in between the outsides of the box at the very least, maybe not the perfect middle, but somewhere in between anyway. So the median of the heights of the basketball players, which you can see in additional example 1, again, it's that same marker, all right, is about 74 and is greater than the median of the heights of the baseball players. And as you can see looking at the graph on the screen right now, it looks like it's right around 70. So in general, the basketball players have a greater median height than the baseball players, which is not necessarily surprising information to us. Which players have the greater interquartile range? Now, we really haven't touched upon the term interquartile range today. We've seen median a few times that we just talked about in A. The interquartile range is the distance from left to right side of the box. I believe they use the term difference in the definition. What they would be applying is you subtract the number that's the right side of the box from the number that's the left side of the box. So we'd be subtracting big minus small there. So the length of the box in the box and whisker plot here for baseball players gaps from what looks to be about 66 to 74. So you'd be doing 74 minus 66 to find that interquartile range, which is about 8. And again, you can look at the basketball players one in additional example 1 here. And what we're going to see is that the length of the box and whisker plot indicates the interquartile range, and basketball players has a longer box, so it has a greater interquartile range. The follow-up question is also based on interquartile range. It's asking which group of players has more predictability in their height. What they're talking about when they're talking about predictability is generally they would be talking about a more narrow box and whisker plot, and it's even so a more narrow interquartile range, which we just learned about in part B there. The smaller the graph, the more predictable, because the numbers have to fall in a more smaller set of numbers. So the range and the interquartile range being smaller for baseball players, meaning that there is less variation in the data, so the heights of the baseball players is going to end up being more predictable. Okay, so let's take a look at the check it out examples here. They're asking us to use the data to make a box and whisker plot. Again, we need 5 numbers. We need the small and the big number to start with. Well, as you can see, I took those numbers that were not in order and I put them in order. 22, 24, 27, 31, 35, 38, and 42. And I need the small and the big number, which are 22 and 42. And those will be the first 2 numbers I'll end up laying down on my box and whisker plot. As you can see, the number line appears at the bottom of the screen with the 22 and the 42. So then what we want to do is we want to find the median of the list. The median is the middle number when they're in order from least to greatest. So I'll count in from the outside as I was due when we find median, and we spy 31 here being my middle number. So 31 is this dot here that ends up being in the middle of the box and whisker plot. That's again going to separate my list into 2 parts. Everything less than the median becomes its own little thing, and everything bigger than the median becomes its own thing. Notice when I separated that list, 31 does not fall into either part. 31 is not on the small list, it's not on the big list, it's just in the middle. What I want to do then is find the median of my small list and find the median of my big list. So in this case, 24 is the middle number here, and 38 is the middle number here. And as you can see, those are also graphed on my number line. Remember, I connect these 3 medians, the lower quartile, the upper quartile, and the actual median with the box. And then the whiskers connect out the smallest number on the list and the biggest number on my list. Okay, now we're going to use the box and whisker plot to answer the question, and the question is, which shoe storage has a greater interquartile range? Again, the term interquartile range refers to the box part of the box and whisker plot. So they'd be asking us really, which is the longer box? Well, what's easy to compare here is because these both basically start at the same spot. So all we have to do is say which one is longer, and clearly maroons is the longer box of the 2 box and whisker plots. So the answer here will be maroon's shoe store. If they didn't start at the same spot, we would just want to check the distances by comparing the number line numbers. This looks like it goes from 36 back to 26. This one goes from 34 back to 26. Subtracting, we would see that the bigger number that results from that subtraction is the number for maroon's shoe store.